What's up, guys? It's Professor Kraus with another installment of AP Chem God. I'm going to be going over the 2016 AP Chemistry Free Response number 7, and I am amped up to do so. So without further ado, let's get this show on the road. Unfortunately, I do not have another theme song today, but let's just dive into it and get started. Alright, so question 7 states, a student is given a 25.0 milliliter sample of a solution of an unknown monoprotic acid and asked to determine the concentration of the acid by titration. The student uses a standardized solution of 0.110 molar NaOH, a burette, a flask, an appropriate indicator, and other laboratory equipment necessary for the titration. Okay, so that's the base of the experiment. And then part A states, the images below show the burette before the titration begins in the below left and at the end point, the below right. What should the student record as the volume of NaOH? So for part A, you have to read the two measurements that they give you on the burette and make a calculation from those two measurements from your own, reading of the measurements. So what you're going to want to do is to find the amount delivered to the flask, you're going to want to take the end reading of the burette and subtract it by the initial reading of the burette. So I will say V delivered equals V final minus V initial. So if we're going by that, the V delivered equals 37.30 milliliters minus around, I would call that 5.65 just to make things easy with the calculations, and the final will be 31.65 milliliters. Now, as we move on, we'll be going on to part B. And part B states, based on the given information and your answer to part A, determine the value of the concentration of acid that should be recorded in the student's lab report. Okay, and then just to throw in C, because why not, we're crazy chemists, in a second trial, the student accidentally added more NaOH to the flask than was needed to reach the endpoint, and then recorded the final volume. Would this error increase, decrease, or have no effect on the calculated acid concentration for the second trial, and justify your answer? So let's get into B, and then we'll hit C right after and just get down to it. For part B of the question, it's saying based on the given information and your answer to part A, determine the value of the concentration of the acid that should be recorded in the student's lab report. So I'm going to just write a list of what we have so far. We have the molarity of the base, which is 0.110 molar. We have the volume of the base now, because of our calculations, which is 31.65 milliliters, or 0.03165 liters. And we also have the volume of the acid, which is 25 milliliters, or 0.0250 liters. And because we have all that and we are looking for the molarity of the acid, we can just plug it into the trusty MAVA equals MBVB equation, as shown. And when you rearrange that, you can do MA equals MBVB over VA. So then when you set that up, that is equal to MA, and plug in the numbers, is 0.110 molar times 0.03165 liters over 0.0250 liters, and that all equals 0.139 molar. So I know I already said C, but just to get it fresh in our minds again, let's just repeat ourselves. And in the second trial, the student accidentally added more NaOH to the flask than was needed to reach the endpoint, and then recorded the final volume. But that's silly. Why would you ever do that? But this kid did. So would this error increase, decrease, or have no effect on the calculated acid concentration for the second trial? And let's justify our answer. So after thinking it over, it was concluded that the mistake would increase the calculated concentration of the acid. And this is because the amount of basic solution needed to neutralize the acid has a positive relationship with the concentration of the acid. So the positive relationship means that as the amount of basic solution needed goes up, the concentration of the acidic, calculated concentration of the acidic solution goes up. So then, as the amount of base needed to neutralize increases, like I said, the concentration increases, since that means there are greater moles of acid in the solution. If the student says that a greater amount of base was needed, or if the student says that greater amounts of base were needed, that means they increased the amount of moles of acid in the solution, which increases concentration. Okay, so now I've prepared a couple practice problems for you guys to do after watching the video. The first of which is A. It takes 83 milliliters or 0.45 molar NaOH solution to neutralize 235 milliliters of an HCl solution. What is the concentration of the HCl solution? And B. A few small drops of water are left in a burette that is then used to titrate a base into an acid solution to determine the concentration of the acid. Will this small amount of water have any effect on the determined value of the concentration of the acid? It appears that's all the time we have for today. Thank you guys for watching. Unfortunately, I don't have any more dog pictures. That was quite circumstantial for the last video, but thanks for watching and have a good one.